Hello, welcome to Homework 19 with Caleb Unger and Nick Losi. This homework focuses in on a procedure that uses Monte Carlo and Bayesian approach to determine failure rates for machines, generating candidate points based off of our prior distributions, and with that we're able to determine through random number generation whether or not to accept the point and determine the probability of failure. So the end goal here is to see the probability of a machine surviving after a certain number of hours. Preferably 1,000, 2,000, and 3,000 is what this problem was tasked with. So as we set up the data in our X matrix and the different parameters that were given, our 1,000, our 2,000, our 3,000 hours, we're able to run through the Bayesian procedure and then compare it against candidate points in order to determine a acceptance or rejecting of the candidate point, and then storing that into a matrix, and then obviously averaging all of those together in order to determine the survivor probabilities, if it survived 1,000 hours, 2,000 hours, or 3,000 hours. So when we run this, we get some probabilities. So if it survives 1,000 hours, our mean probability is going to be 0.67, and according to the book, that is very close to what they got, because the book for 1,000 will get a very similar answer. And for the 2,000, it gets another very similar answer. It's 0.45. For that one, we get 0.44, technically 0.438. They get 0.4529. And again, for the 1,000, they got 0.6952, and it may just be a difference in our seeded random numbers. And for 3,000, we get the same thing. It's 0.28, and they get actually 0.28. We get the exact same thing for surviving 3,000 hours. And if we look at our graphs, they show the same amount of kind of walk distribution and variance in that walk as the example shows in the book for 1,000, 2,000, and 3,000 hours. So thank you for watching, and I hope you find this helpful.